So this morning I was browsing through this list of chemicals and their various smells, and I stumbled across something odd. Yeah, so apparently this chemical is supposed to smell like nut. It seems like a very odd smell, so immediately upon seeing this I'm like, yes, I need to smell that. So if I wanted to smell this chemical, I could order a little bit offline, have it shipped to my house, and then give it a little smell. But then I remembered, I'm an American. And here in America, we don't just buy things. We spend hours, tedious hours, working away, designing a worse version of something that we could just buy for a lot less money. So I decided I'm going to make it myself in my garage. So looking at the chemical, there's a lot going on here. But in order to figure out how we're going to make it, we need to reverse engineer it. In a sense, we're trying to decide what pieces we do have that we can use to make this final product. Right off the bat, I see an ester in the middle, and esters are very easy to make. You can make them by combining an alcohol and a carboxylic acid, and I've done this many times before. It's very easy, and I actually happen to have this propanol from another ester that I made in a previous video. The benzoic acid on the other side, though, I don't have that. I could buy some, but I want to do this now. I want to start doing this immediately. So maybe we can make benzoic acid. Well, I actually seen some stuff online. You can actually make benzoic acid from toluene, which is a common paint thinner. I actually have toluene and I have potassium permanganate, which you need to turn it into benzoic acid. So we'll do that. We'll make the benzoic acid from the paint thinner, and then we'll combine it with the propanol and we'll have nut smell. Okay, to start off, you may notice this is a bit of a different POV. If you guys like this POV, let me know. And if you absolutely hate it, also let me know. I couldn't find my proper lab glasses, so we're gonna be wearing these today. It's better than nothing. Okay, to start off, this procedure is modified slightly from Wheeler Scientific procedure, so you go check out his video because it's probably better than this one. So to start off, we're going to add 35 grams, and try not to dump all of it. Yeah, awesome. We'll take care of that. Next we add 250 mils of water with 2.5 grams of sodium hydroxide added. One of the benefits of this POV is if everything blows up in my face, you'll be able to see it clear as day. Now this is actually not particularly dangerous. Then we add 30 milliliters of toluene. If you watch the Wheeler Scientific, he pronounces it a little differently.
30 milliliters of toluene. The toluene is in stoichiometric excess.
Kind of funny, but I mean, thank you for the procedure. So we're going to heat this up, and to prevent the vapors from sort of escaping, we're going to put this reflux condenser on top. Now, one of the problems with this reaction is that the toluene floats on top of the water, as you may be able to see, and that's not good because the reaction is only happening at the thin little place where those two layers intersect. So we need to add plenty of stirring in order to get this to run as we want it to. The more stirring, well, to a point, the more stirring the better. Now in this case, the water is a solvent and the sodium hydroxide is sort of important for the reaction. Not to go into too much detail about how this works exactly, but a little thing you should know about organic chemistry is what oxidizers are. Oxidizers are effectively chemicals that sort of level up other functional groups on molecules. The most basic form of this is when you have something like an alcohol and you sort of level it up to an aldehyde or a carboxylic acid. You can also level up aldehydes to carboxylic acids. That also works. In this case, there's some sort of funny chemistry going on. A lot of times you think of these basic oxidations happening to alcohols and aldehydes, but in this case, toluene has this sort of unique structure that allows for the carbon to oxidize into sort of an alcohol and then an aldehyde, and then it goes all the way to a carboxylic acid immediately. So yeah, in principle, we are sort of oxidizing the toluene, sort of leveling it up to the level of a carboxylic acid, or in this case, benzoic acid. Now, an important thing to note in this reaction is that the toluene is in excess, which means that all of the potassium permanganate will sort of react away, and then it'll turn into solid manganese dioxide, which does not dissolve in water, and it'll just be sort of brown sediment that floats to the bottom. Okay, so after several hours of reacting, we are now back, and you'll notice that the color has changed from a pinkish purple, bluish color to brown. That means that all the potassium permanganate has changed oxidation states, and basically now it's all solid brown manganese dioxide, which doesn't dissolve in the water. It's just sort of sediments that are floating around in there. So to remove the manganese dioxide, we are going to filter it off. Shouldn't be that difficult. Oh yeah. And the camera cut out. Okay, so it seems like we have a bit of a problem here. The toluene, oh, let me down. The toluene seems to have gotten very thoroughly mixed with the water. You may notice the toluene's not really floating on the water. I don't know if you can see that. And that means that it's thoroughly mixed in, which you may know. Toluene and water don't usually mix. Usually toluene floats on water because it's less dense and it's very nonpolar, but if you really mess up, you can get an emulsion, which is basically where you get little droplets of toluene sort of floating around in the water, and they don't like to separate. Alrighty, now you want to put everything into a separatory funnel. Okay, so you see there's two layers here. The top layer is the toluene, and the bottom layer is water that seems to be very thoroughly mixed with toluene. So this is where we get into some trouble. I'm going to go ahead and add a little bit of salt. This is just sodium chloride. The sodium chloride, this isn't lab grade, unfortunately. The sodium chloride, basically what the salt does, the sodium chloride, it dissolves in the water and creates a bunch of sodium chloride ions, and those ions sort of increase the polarity. It's kind of, it's probably way more complicated than I even understand, but I just sort of remembered as they kind of increase the polarity of the water, and that makes it so the toluene does not like to stick around. Okay, it's all dissolved. So now we play a waiting game. I'm going to wait 6 or so hours for it to improve, and if it doesn't improve by much, we're going to have to resort to different methods. Okay, okay, that's awful. Okay, so clearly that didn't work. We left it for several hours and that did nothing. I guess the next resort is we have to go completely cursed. Now, I didn't want to do this, but there's this particularly cursed episode of Hamilton Morris where he meets some drug chemist and he has a solution for dealing with emulsions like this.
And an emulsion is broken with a vibrating dilding apparatus.
So that I mean, this is the right spot.
Okay, let's see if we can get this wired up. We're wiring this into a power supply because I don't want to run this on batteries all day. Okay, we're gonna have to censor this. This may be a little too hot for YouTube, but yeah. Okay. If this works. Oh man. Why did that have to work? Alright, I guess that's going in the video now. Okay, so as you can see, it's mostly clear, which means that the emulsion is mostly broken, which is, I actually didn't expect that to happen. If you look up online, can vibrations break emulsions? They're like, yeah, but you need ultrasonic waves to break emulsions, but apparently, apparently this sort of wave works too. So we separate that from the toluene. or we're going to call that, yikes. Okay, now that we have the toluene gone, it's mostly just benzoic acid and water. There's also sodium hydroxide, which makes the whole thing basic, and that's actually an important detail. Because the sodium hydroxide is basic, we can think of the hydrogen on the benzoic acid as gone. It's already been taken off by the sodium hydroxide, and we have a salt. And salts are very soluble in water, that's why it's dissolved in the water. But if we add a very strong acid, we can put the hydrogen back onto the benzoic acid, and benzoic acid by itself is actually not very polar. It looks sort of polar, but it's kind of confusing. All these carbons make it nonpolar, and because it's nonpolar enough, it's not going to dissolve very much in the water. So as soon as it's formed, it'll sort of crash out as a precipitate. Okay, so you'll notice as we add the hydrochloric acid, the hydrogen is immediately transferred, forming white benzoic acid. Now, this white benzoic acid powder quickly started to foam up, and I was actually terrified that it was going to overflow. Okay, so that was actually terrifying. I thought that was going to overflow there for a second. But no, it looks like sort of deflated. I didn't expect that to happen. Normally the precipitate just sort of forms there, but I think because I added so much of a very strong base to a really strong acid, it started boiling or producing a lot of gas. Also, hydrogen chloride produces gas by itself. Not entirely sure, but it's very fluffy and very interesting. So the next step, we're going to filter off the benzoic acid, which has fallen out of solution, and then we're going to dry it. Alrighty, then for the next step, we just add the benzoic acid to a little oven, and this is to drive off all the water. It actually smells like a hospital in here. Something about the benzoic acid is this like very strong hospital smell. Not really sure what that is. Alright, so we got this benzoic acid. I gotta fold it up in a paper here so that we can transfer it easier. It smells like a hospital. If you've ever been in a hospital, for some reason it smells like that, but like very strong. It's sort of stinging up the whole lab, so we're gonna go ahead and put it in there. Perfect. Then we're going to go ahead and add 1 propanol. This is also known as propyl alcohol. It's like isopropyl alcohol that you may see at the store, but instead of the alcohol being in the middle, it's on the end. Not the same thing. All right. Now there's not like an exact amount because technically the alcohol is going to be in excess because it's everything's sort of dissolved in it, so that's sort of unavoidable. And we're going to add a few drops of sulfuric acid. That's probably more than enough. The sulfuric acid is catalytic in this reaction, which means that it doesn't need to be measured out either. I gotta add this little puppy to catch all the vapors so we can run this for a long period. Now, essentially what's happening here is a reaction called a Fischer esterification. We've done many of these on the channel before, but essentially what happens with the Fischer esterification is a carboxylic acid group and a alcohol group link together to form an ester. In this case, the ester that's being formed is propyl benzoate. Propyl benzoate is a naturally occurring ester that gives certain fruits and things their smells. Here's a list of some things. It's got some other applications, but really we're just in it for the smell. So we're going to leave this for 8 hours to make our final product, and then we'll have to clean it up a little bit. Okay, and we're back. I did not leave the fume hood on undernight to suck up all the vapors. I didn't really think it was all that necessary, and I'd rather it be sort of warm in here. But then when I came back into the lab for the first time, it smells like a butter pecan pie. It's a very nice, sweet, nutty scent that I'm getting in this lab. So hopefully we can sort of isolate that in this oil. So now we should just be able to do some purification steps. So for the first purification step, actually let me give this a little smell. Yeah, it just smells like alcohol because there's still unreacted propanol and unreacted benzoic acid. So yeah, it mostly smells like alcohol, maybe a little benzoic acid smell. So, okay, make sure to stop. The clock is closed. Okay, so we pour everything out, and then we add a little bit of water. Now, the point of this is we're going to attempt to remove the propanol, which hopefully dissolves more in water, hopefully, and the sulfuric acid, which is almost certainly going to dissolve better in the water. And we should get a nice layer of some sort. It's possible that we don't have enough water. Let me try. This is water, right? Okay, I think we had just enough water, and now we have a lovely little emulsion. Now we just need to wait for the oil to separate. Okay, that worked a lot better than I thought it might have. We're going to extract the bottom layer, and then we're going to pour off the top layer, and we're going to see what we're working with here. Still smells like propanol. I imagine a lot of the propanol is still dissolved in there. Maybe a little benzoic acid smell. So what we're going to do is we're going to add a basic solution of water. Now, as we talked about before, benzoic acid is not very water soluble because it just sort of came out of water. That means it's probably stuck into this oil layer, which means we need to add some base, in this case, sodium bicarbonate. That'll react with the benzoic acid and make it a salt again, which will put it into the water layer. Oh yeah. Okay. Maybe it smells a little nutty, but I don't really think the one propanol is washing out, so I think we're going to go ahead and do a distillation. Alrighty, to finish this off, we're going to do a short path distillation. Not the best at separating things, but we have a very small batch, so I just want to see if we can get even a little bit out. Alright, so now the distillation's going on. We're collecting all the vapor, it's distilling over nicely. The first bit should be propanol, and then it should start to change scents, and it should also sort of switch over to the propyl benzoate. The distillation's starting to slow down and the temperature is holding. I think that this is a sign that the propanol's gone and we're starting to switch over to... Oh yeah. Oh yeah, I can smell it. Okay, I'm gonna switch collecting flasks and we're gonna start running that now. It smells like a cinnamon roll. I'm not gonna ruin the result, but there's definitely some smells going on. Okay, so here's the final product. Let's give it a little whiff. Okay. So I smelled this a little off camera. Let me just say, this is probably my favorite smell that I've made in the lab. It is really good. If you really get your nose into it, it's kind of gross, but if you let it sort of soak into the air, it creates this lovely, warm, like, pecan pie smell. It's delicious. I'm not even kidding. When I first came to the lab before, it smelled like somebody was baking a pie. It's so good. I understand why they use this in like artificial flavorings and stuff like that. I'm not going to try it myself because I made it with drink cleaner, but it is actually quite pleasant. So yeah, there you go.